Okay, here we have an elastic rope fixed at point O and pulled out to a position A, and it's on a rough table, so we have friction, and we're told the mass is m, so the normal reaction would also be m, and there'll be a tension in the rope pulling it back. Okay, so the tension is pulling it to the right, therefore friction is opposing motion, goes to the left. Now we know that T is lambda x over L, Hooke's law. Lambda, we're told, is 3 mg. The extension, the natural length, is L, and we're told this is 7/6 of L. Okay, so this length is 7/6. So the extension is 1/6 of L, and then we divide by L. Which equals 3/6½ mg. Oh, it's not half, so it's only half mg. We could write that as 4.9g, we could write 4.9 m, but anyway, half mg. I'm going to keep it in g's for a moment. Now, I've got to show that coefficient of friction is greater than half. So I know, because it's not moving, I know I'm not in, so I know that friction is less than or equal to mu r. It could be on the point of moving, I don't know, but it's not moving at the moment, so I know this is not equal. Sorry, it's not definitely equal. So friction is got to equal T. So friction equals T, which is a half mg. And we know that R equals mg. So friction less than or equal to mu r. Friction over r is less than or equal to mu. Half mg over mg is less than or equal to mu. So we end up with mu is greater than or equal to a half as required. We're now told it's released, it's moved along the table, so a separate diagram, don't rely on the same diagram. Okay, so we've got it here, fixed at point O, this is at point B, diagram is very similar, mg, and R equals mg, same as before. We've got friction going this way, and we've got tension going this way. Okay, and we're interested in you know it's moving, so friction is at its maximum to optimum, and we're looking for when it becomes slack. So we call that point C, where this is L. Okay, so we know the friction because it's, and we know mu is a half, so we know that friction is whatever it was up here, half mg. Okay, friction equals mu r. We know r, we know mu is a half mg, same as it was up here. Okay, so we've now got tension in the string initially is lambda x. I'm sure we need this or not. I don't think we need this, to be honest. No, I don't. So we won't worry about the tension. This is going to be a work energy situation. So energy at, oh, so we'll need this. Oh, energy at A So energy at B. We've got elastic potential energy plus kinetic energy. It's not moving because we've got it in place, so we've got a half lambda x squared over 2L. Up. Lambda is 3mg. So we get 3mg times a half L, because it's expanded from 1L to 1.5L, squared. Natural length is L, so that's 2L. Take away any work done against friction. So take away work done. Take away friction, which is a half mg times the distance it's moving, times d, and we know that must equal 0 because it's when the string, oh no, it's not 0. Let's see what's going on here. Okay, so it doesn't equal 0, so this equals the kinetic energy at the end, which is mv squared over 2. I know the distance is L over 2. Right, it's okay, sorry. So we've got 3 mgl over 8. Take away, this is gml over 4, because the distance is a half L before it becomes slack, equals mv squared over 2. Okay, so then I've got times it all by 8. I get 3mgl, take away 2mgl equals 4mv squared, which gives v squared equals, the m's will cancel, gl over 4, which implies that v is square root of a quarter is a half root gl. Okay, right, and then the final part, the total distance before it moves again. This time we're going to do the energy. We can either do the energy at B, take away work done is 0, or the energy at A, take away work done against friction is 0. Let's do energy at A, take away work done against friction equals 0 because it stops. Energy at A we know is mgl over 8. Okay, that's from the previous part. We know work done against friction is g over 2 half gm times the distance it's going to travel equals 0. Rearrange that. G's will cancel, the m's will cancel. We get times by 2, so we get L over 4. So the total distance would be the half L that it takes to get from B to A, plus this extra quarter L, which is 3/4 L. Perhaps it will make a little bit more sense to do the energy at B, same thing, but do energy at B, which is in fact 3mgl over 8. Take away gmd over 2. And if you do that, you get D equals 3L over 4 in one go.